simple.
Sorry, doctor, the same problem. I think you need to switch from your headphone. I think your headphone is having problem. If you can just remove the headphone and speak normally, and then I would think we rectify that. I think headphone might have problem.
Your phone problem. Then another students have problem also not listening to me and this explanation.
No, everything is fine. I think just the headphone. If you're using an headphone, okay, we are struggling to hear you at the same time.
Okay, okay. Yes or no? Effect of hyperglycemia, glucose reabsorption analogy. You know this parasyllabus summary absorption of this PCT reabsorption descending profile. Okay. Now, if you understand, I continue answer this quiz. Not I, you. Help me and answer this quiz. The first is done. I second.
Your voice is still cutting off. We still can't hear you.
Repeat, please, what you tell.
We're saying your volume is still going up and down. We still can't hear you.
Volume of which is my voice.
Your voice, yeah.
No, I didn't know why it's a problem. Okay, no, I listen good. You answered me these questions, okay? I listen good your voice. First, I this membrane locations, the same question. These are sodium, potassium pump, potassium passive. These are active channels. These are glucose channels. These are sodium chloride, potassium channels. Also, you know which are I have in this distal convolution support descending group of friendly arteries. Different types of this co-transport channels. Yes, example sodium chloride potassium channels, chlorodiuresis and sodium glucose channels. First questions: membrane location. I click this 20. Please, I repeat this again. This sodium potassium pump are location in
basolateral.
First is correct. Okay, you remember transport mechanisms. I in this basolateral membrane. It's not on. Okay, potassium channels, which is no, it's not also. Internet. If you this quiz are need internet, and sometimes if internet is. Okay, I think at this moment you have internet not opening these questions potassium. Okay, no, which is player. It's very interesting questions. You first answer this effect of furosemide and diuretic, and after again enter. Click the furosemide button to see medication action upon the ascending loop of Henle. This one, which is this ascending loop of Henle, and these are different types in ascending loop of Henle. Also, one has this simple cuboidal epithelial cells, different types of transport to edema is a presence of excess fluid in the extracellular portion of the body. When edema becomes serious, as in congestive heart failure, drugs called diuretics are given. Are given to reduce this maximum given to reduce the excess. The fluid furosemide is a powerful diuretic, often called a loop diuretic. Why? Because it blocks sodium, Cl, and potassium co-transporter in the luminal membrane of the ascending loop of Henle. These channels are blocked. Okay, understand? As these channels are blocked. You click this furosemide. Yellow colors means it blocked these channels. Next, when furosemide is administered, the medullary osmotic gradient will become more concentrated. Dilution or filtrate in this ascending loop will be impaired, or fewer solutes will be delivered to the collecting duct. Which is correct? First, second, or third?
The first one.
First one is correct. No, the decreased reabsorption of ions from the ascending loop reduce the solute. 1 minute, explanation. Solute concentration in the medullary is interstitium. Which one next?
The fewer solutes will be delivered.
No, more solutes will be delivered due to the reduced reabsorption. No, correct answer is that is correct. Without the removal of solutes, the filtrate will not become more dilute as usually occurs. The ratios of filtrates in the ascending loop will be impaired. Okay, understand this? What are makes this furosemide? Furosemide are block this co-transporter in the ascending loop of Henle, which are have the same histological structure, simple cubical epithelium, but different. First time it has this few this microvilli, more microvilli are in this proximal convoluted tube, and those are different types of transporter. These are potassium channels. Okay, if I enter this membrane transport tree is very interesting. You remember this old type of transport and ions. Repeat again if answered again. No first questions you answered this basolateral membrane. Next. Okay, eyes open. How in this transport mechanism classified? This
ATPase pump.
ATPase pump. Very good, it's correct. Next, transport method. Which is method?
Primary active transport.
Primary active transport. Very good. Your answer is correct. Potassium ion channels. These are passive channels. Yes. Where location? In which membrane region is this transport protein found?
Basolateral.
Basolateral. Only basolateral. Click this or both. No. Or both. This one. Yes.
Luminal.
Luminal. I tell both, but you answer 1 minute ago you see, but this boat, okay, again I entered, no problem. But it's very interesting quiz. If you answered all correct, then you remember this type of transport in this basolateral membrane and in the luminal membrane. First time answered this potassium.
That'll be both basolateral and luminal.
Okay, good, both. Transport mechanism. Which type of channels you see? Which is? Not
Counter transporter. Counter transporter.
transporter, you see this passive channels with the potassium ions. Facilitated diffusion, no. Co-transporter, no. ATP pump, no. Which is? Ion channels, yes, it's ion channels, yes. Next, transport methods, which is type of methods? Which is type? Active, no. Solvent drug, secondary active, facilitated diffusion via carrier. Facilitated diffusion via channel.
Is it
Final, which one?
diffusion via channel?
Diffusion, this one, via channel, this one.
Let's say
Okay, correct.
No, solvent drugs. Oh, okay.
Okay, you understand this first and second. Sodium potassium pumps location in basolateral membrane, transport mechanism, which type? Active transport and transport method, primary active transport. potassium ion channels, location in this basolateral and luminal space, and these are transport mechanisms. These ion channels is passive transport, yes, always so. Transport method, facilitated diffusion via channels. Glucose, if you open glucose, glucose via location, in which membrane region is this transport protein found?
Luminal.
Luminal. No. Next. Next. This type of channels where you see, I tell this facilitated diffusion.
Basolateral?
Basolateral membrane. In basolateral membrane, where glucose are transported by facilitated diffusion. Transport mechanism, which type? Repeat, please. Which type?
Co-transporter.
Co-transporter. I tell that in this location, in this
Oh, this is a facilitated diffusion transporter.
facilitated diffusion transporter. I tell the facilitated diffusion, you tell me co-transporter. Okay, transport method. Which is transport method? Facilitated diffusion via carrier, facilitated
Via channel. Facilitated diffusion via channel.
Via channels, no. This one. Via carrier, facilitated diffusion via carrier is a transport method of this glucose. Okay, I just first also repeat this first. Basolateral membrane. Next, remember this all. And I again enter and answer. Transport method, which type of transport method? Which is? ATPase pump.
ATPase pump.
And this one, which is? Primary active transfer. Primary active basolateral, this one. Sodium channel potassium. These are also co-transporter. Yes, where location, I repeat. Remember, if you remember, where location. This type co-transporters channels are where location. In which side?
Luminal.
Luminal. Very good. Next, transport mechanism. Which is transport mechanism?
Co-transporter.
Okay, good. Co-transporter, good. And the transport method, which is?
Facilitated diffusion via channel.
It's correct.
Secondary active transport.
Secondary active transport is correct.
Sorry, secondary.
Yes,
Yeah.
these are also correct. Next are chloride ions. In this where location, chloride ion channels in which membrane, which is
Basolateral.
basolateral membrane. Correct. Very good. Transport mechanism. Which type of transport?
Ion channel.
Ion channels. Okay. These are passive channels. Okay. And transport methods. Which type?
Solvent drag.
Which is solvent drug? This one. No. No. Fantastic. Okay, no problem. I enter again. These are ion channels, yes, and sodium glucose. Okay, again. Begin from chloride ions. Where location? Repeat.
Luminal.
Luminal. Oh, yeah, I click incorrect. Yes, luminal.
Basolateral.
Basolateral. Transport mechanism, which is?
Ion channel.
Ion channel.
Yes, and the last is the transport methods.
Facilitated diffusion via channel.
Okay, correct. Last is a sodium glucose channels. Sodium glucose.
Luminal.
Okay. Luminal. Correct. Yes. Next. You tell me transport mechanism, which type of transport mechanism? Luminal, sodium glucose.
Secondary facilitated
Active
diffusion.
transport, yes, secondary active transport, and the transport method. Secondary active is a co-transport, is a simport, yes? Okay, I open again this and please answer all students and then take photo and remember, these are very interesting quiz, but you see these all types of channels and where each location. Okay, please. Another student, girls, with same these passive channels. Why not answer these girls? Only boys I listen. Which is membrane location? Where location? Sodium, potassium, pump. Where location? Please repeat.
Basolateral.
Basolateral. Okay, our same boys. Transport mechanism. Transport ATPase pump, yes. And transport
ATPase.
method, yes. And transport method is a which one? Okay, it's not respond. Okay, now first you answered all. Which is the second? Also has the second games. Number two. Number two. Let's play now, player two. Okay, sodium potassium pump membrane location. It's the same on what is this? YH2. Okay, what is difference first? Where location repeat the sodium potassium pumps based on it's the same. Why it has this questions? Okay, no problem. Transport mechanism, please. Transport mechanism.
ATPase.
Pump. Okay. Next. These are transport methods.
Primary active transport.
Okay, good. Next, potassium ions, membrane location, where location? Where location? Potassium.
Basolateral luminal.
Another who answered next? Potassium channels are location in both, yes? There's a lateral and luminal space. Transport mechanism, which is transport? Passive channels, yes? Ion channels.
Ion channel.
Yes, and these transport methods? Facilitated diffusion via channels, okay? Next, glucose in this membrane location. Where this location in this basolateral membrane? Next, transport methods. Which is transport methods? Not open. Which is transport methods is a facilitated diffusion, yes? And this one, facilitated diffusion via this carrier, it's answered. Sodium, potassium, these are second types of co-transporter. Where location? In which membrane? In the ascending group of Henle, yes? And which is?
Luminal.
Luminal, very good. Correct. Next, transport mechanism. Which type of transport mechanism?
That is co-transporter.
Co-transporter, very good. And these last transport methods of co-transporter are?
Secondary active transport.
Bravo, bravo. Very good. Next is Cl channels, chloride channels. Their location?
Basolateral.
Basolateral membrane. Next type of transport mechanism, which type? Which type of channels? Passive channels. Type of transport, which is?
Ion channel.
Okay, ion channels. I'm clicking on ion channels. And this one, how this transport method classified?
That's a facilitated diversion via channel.
Okay, and last, sodium glucose channels, their location. Membrane location in this which space? Luminal space. In luminal space. And transport mechanism, which type of transport? In luminal space, which type of transport? If both ions enter, it's named co-transporter, yes? And if co-transporter is which type of secondary active transport, okay? And this last, which is questions, transport mechanism from this one is facilitated diffusion transport, yes, okay? And this transport method, which is transport method? Facilitated diffusion via, okay, please, I take photos, this one, okay, I or share screen, click this flag and near this F12, okay. Remember this type of transport tool? Yes or no? I repeat, sodium potassium pump are substance transported via location first time. This location in basolateral membrane. These are in both basolateral and luminal membrane. This glucose channels located in basolateral membrane. In luminal membrane, this sodium channels, sodium chloride, potassium co-transporter. Next, these are Cl passive channels in basolateral membrane also. In luminal membrane are sodium glucose channels. Which type of substances are transported? These are sodium and potassium from ATP, which are used this ATP energy. This ATP is pumped. Three sodiums are pumped from inside to outside, and two potassium ions from outside to inside. And what is this name? It's named primary active transport, but why you use this ATP energy? Next is a potassium ion channels is a passive channel. It's always open. You did not need the energy from transport from high to low concentrations. This is ion channel. Facilitated diffusion via channels. Glucose channels are located in basolateral membrane. It's a facilitated diffusion transport via carrier. And these are sodium channels and the chloride and potassium channels, also co-transporter, which are location in luminal space where, in which part of this nephron, ascending group of Henle, yes, these are ascending group of Henle, which are also are simple cuboidal epithelia, which are co-transporter, which are secondary active transport. Chloride ions, same as potassium channels are location in basolateral, but instead of this luminal, no, basolateral membrane, it's ion channel and facilitated diffusion via channels. And this one also sodium glucose luminal. Okay, understand this quiz? Yes? Break time. Okay. Want break time or not? 10 minutes? Yes or no? Okay. Continue after 10 minutes. Next quiz about increase or decrease furosemide. First time, please answer me. Click this decrease or increase, and then also different furosemide loop diuretic. Increase or decrease? Which one first? Which is click? For example, furosemides in loop of diuretic are decrease. Next, which is increase or decrease? Sodium, potassium, Cl,
Increase. Increase.
increase. Next, first time answer done, and then I click check answer.
Increase.
Next,
Increase.
you answered increase. Sodium, potassium, Cl. Next, interstitial osmolarity.
That's
Increase or
that will be increase as well. Increase as well.
increase osmolarity. Water reabsorption is in a descending group of handling.
That decrease. Water reabsorption
Decrease.
decrease.
Filtrate, volume, and flow.
Is water reabsorption decrease? That's osmolarity increase. Filtrate will increase as well.
These are water volume and flow increase or decrease?
Increase.
Increase. Urine output.
Don't know.
One of this answer. Then I click check answer. And loss of body water and electrolytes. Increase or decrease? Urine output.
Urine should decrease. That's what I think. Well,
Decrease and loss of body water and electrolytes. Which one?
Increase.
Increase. Okay. 1, 2, 3. I click check answer. All are incorrect. Again, answer that is only one correct. When decreased, furosemides are sodium, potassium, Cl, co-transporter are increased. Next. Which one? This, I think this is incorrect. This also incorrect. This change, this all correct. This one, and this also. 1, 2, 3. Okay, help me answer these questions. Sodium, potassium, Cl is decrease. Next, this interstitial osmolarity.
Increase.
Increase. Water reabsorption in descending loop.
Increase.
Increase is correct. Filtrate, volume, and flow.
Increase.
Increase. Urine output.
Decrease.
Decrease. And loss of body water and
Decrease.
electrolyte.
Decrease.
Decrease. 1, 2, 3. Before is all correct. After these 3. When furosemide is decreased, sodium Cl.
Filtrate volume will decrease, urine output will decrease, and the water loss of body water will decrease. So change the filtrate volume to decrease.
These all decrease.
Yeah.
These are correct. Okay. Understand this or repeat? When decrease, sodium Cl, potassium co-transporters increase. After this return to tubule are decreased, interstitial osmolarity increase, increased water reabsorption in descending loop, filtrate volume and flow decrease, urine output decrease, and loss of body water and electrolytes also decrease. Next, glucose and sodium reabsorption. First, increase or decrease basolateral sodium potassium pumps by clicking an arrow in the top left box. This one, which one? First, which is click? Increase or
decrease. Decrease. Decrease.
Okay, decrease. Next process. Intracellular sodium concentration.
Decrease. Decrease.
Decrease.
Yes, please.
Next, luminal co-transport sodium and glucose.
Increases.
Increases. Next, intracellular sodium concentration.
Increases as well.
And facilitated diffusion of glucose.
Decrease.
1, 2, 3. Please click in a row in each box. Okay, repeat again answer. First, if you want to decrease basolateral sodium potassium pump, decrease.
Decrease.
If sodium potassium pump decrease, sodium potassium pump's function, what is this? Pump sodium out and potassium in, yes? And if intracellular sodium concentration, if this basolateral membranes in sodium potassium pump are decreased, intracellular sodium concentration increase or decrease?
Increase.
Increase, okay. If intracellular sodium concentration increase, then luminal co-transport sodium and glucose increase or decrease? Sodium decrease. If decrease this luminal co-transport sodium and glucose, intracellular sodium concentration are increase or decrease?
Decrease.
Decrease. And facilitated diffusion of glucose if this intracellular sodium concentration decrease, facilitated diffusion of glucose. Is which one?
Decrease.
Decrease. 1, 2, 3. No, it's not response answered correct. I think it's all correct. Water reabsorption in proximal convoluted tube. Increases in basolateral sodium potassium pumps increase. After intracellular sodium concentration increase or decrease if basolateral membrane sodium potassium pumps are what increases? The sodium concentration intracellular decrease or increase?
How decreases?
Decreases. Correct. Interstitial osmolarity.
Decrease as well.
Increase.
Increase. Osmolarity increase. Next, transcellular diffusion of water, para-transcellular diffusion of water.
Increase.
Increase. And water and sodium reabsorption.
Decrease.
Decrease. Increase. Oh, goodbye. These are Tbilisi daily train, yes. Permeability loop of Henle. No, these are very easy, I think. Click and drag the correct symbol in to identify this permeability characteristics. Which one? These are no, these are discontinuous, these are ascending loop, or these are descending. Which is symbol I write?
PCT ascending.
No, this
Water inhibition. PCT ascending. Water
ascending.
inhibition. Water inhibition. That's it.
1 minute. These are ascending loop, these are descending loop. In ascending loop of Henle are permeability, which is substance.
Oh, PCT descending, water inhibition.
Water. You tell me this one. In here. These are, my dear, listening me, these are PCT. After PCT is a descending loop of Henle. These are ascending loop of Henle, as these are distal chronology too. You know, but descending loop of Henle permeable for water, but not sodium Cl. Yes? And in this ascending loop of Henle are not permeable to water, opposite of this descending loop. Okay? Vasa recta, next. Vasa recta, you know, these are blood vessels which are around this loop of Henle. Why does blood moving down the descending portion of the vasa recta? Lose water and gain sodium chloride. Which one is correct? First,
All of the above.
all. This one. No. Next. First,
If not that one, it will be second one. Will be second one the answer. If not that one, so it will be second one probably.
This one.
No, yeah, that one.
This one. Or this one. These are correct. Because of concentration of sodium chloride is higher in the interstitium than in the blood. These are correct answer. Next, vasa recta 2 and vasa recta 3. These are blood vessels which are around this loop of Henle. Next questions. Why does the blood more slightly in the lower vasa recta in lower? More than one answer may be correct. Which one? Which one is correct, please? First, second, third, fourth. It's osmolarity.
I think osmolarity decrease.
This one? No. Next. Which one? Right? For three options, 2 is correct. For 3, 2 is correct. Which one? First correct. If has become sick because of losing water in the interstitium. Correct? Yes. Next, it is too far away from the arteries, or it has an increased solute concentration, as these 2 are correct. And last questions in here. Which one is correct? Because of the hydrostatic pressure of the blood, which is questions. Why does sodium chloride leave the blood in the ascending vasa recta and return to the interstitium? Because of the hydrostatic pressure of the blood, because of the osmotic pressure is one correct answer only. Because of the lower sodium concentration in the interstitium. as blood ascends and plus it is pumped out by active transport. But which one is correct? 3, 2, 1. Please answer one of these. 1, 2, 3, 4. Which one?
2 is correct.
3 is correct. Good. 3 is correct. So you answered these all questions. Okay. Next about urinary systems, I have this histology works quiz. Urinary, where is this one? Urinary. This is urinary. Connecting. Muscle. Lymphatic. Documentary, respiratory. Urinary. These questions you answered or no? Yes or no? Please answer me. This histology crossword you answered that or not? Didn't remember.
Yes, yes.
Done?
Yeah, I feel like we've done it before. I feel like we have.
They answered yes, these questions, these urinary systems. Or no?
Yeah, I think we've done it before. We've done it before.
Done.
Yeah.
Okay. No, if done, no problem. But next in urinary systems also I have about electrolytes. No, these are you see these questions as you watch the simulated drop of filtrate pass through the renal tubule. Answer the following questions. Click the box to select your answer. More than one may be correct. First questions. In which region of the tubule does the filtrate become more concentrated? In PCT, the second, the thin descending loop of Henle, thick ascending loop of Henle, cortical collecting.
Sorry, we can't see your screen, please. We can't see your screen, doctor. Your screen.
Okay. Okay. You cannot see. Yes, you can see. You see this. In which region of the tubule does the filtrate become more concentrated? More concentrated in which part? PCT, thin descending loop of Henle, thick ascending loop of Henle. These are cortical collecting tubules and medullary collecting tubules. In which regions I more, which is questions, click the box to select your answer. More than one may be correct. Please, where you see this more?
Loop of early. That's why between 1,200 and 1,400. So loop of early.
In here, yes. But loop of Henle has this descending and ascending loop. In which is?
I'd say descending.
Thick descending loop of Henle 1. Yes, the cells are permeable to water, but not solids. And next, so these are only one questions. One answer is correct. Yes, I think it's only one. Next question, tubular region actuates number 2. In which region of this tubule does the filtrate become more dilute?
Ascending loop of Henle.
This one? Yes, the cells are permeable to solids. Water remain in the tubules. Good. Very good. I listening girls, boys. Only boys answered. In which region of the tubule does the filtrate volume change? Volume.
Well, you are the medullary collecting duct.
Which one? You see this one? Cortical or medullary? Which you tell? I repeat, please.
Medullary collecting duct.
Medullary collecting duct, yes, are provided when antidiuretic hormone is present. Antidiuretic hormone or vasopressin. Another, this one, 65% is reabsorbed here. Yes, in this proximal convoluted tube. So then another is all cortical collecting duct. Yes, provides an attention is present antidiuretic hormones. Okay. And the next, dehydration effect. Dehydration, water loss in plasma, more concentration. I first start dehydration. First, increase or decrease dehydration, which is click first. But then another also different, which is dehydration clicks or first increase or decrease, which you want.
Decrease dehydration, decrease,
Okay.
decrease urine.
Dehydration decrease, but next steps, body water. If
Increase.
dehydration, body water increase.
Increase.
Next, blood osmolarity
Decrease.
decrease. Antidiuretic hormones release from pituitary gland.
Decrease.
Decrease. Water permeability of collecting ducts.
Decrease.
Water reabsorption.
Decrease.
Urine concentration.
Decrease.
And urine volume.
Increase.
Increase. Correct answer. It's for you. Dancing for you. You answered all correct. Please tell me your name.
Mohammed Ibra.
Repeat.
Muhammad Ibrar.
Muhammad. Muhammad, where you live? Where are you from?
Birmingham, United Kingdom.
From United Kingdom.
Yes.
Oh, very interesting. You my friend on Facebook or no?
I have Facebook, yeah, but I don't think I've got you as a friend now.
No, you found me and sent me a message.
Okay, I will do.
Lali Modebadze, my name and surname.
No problem.
Okay. You are good students and smart boys, I think.
Thank you.
Okay, welcome. Next questions. Next also very interesting quiz. Match each of the urine samples below with one of these conditions listed on the What is this? On this chalkboard, click first because to make a simple, then click the Analyze Urine button to have it analysis, and then click and drag the letter from the beaker to its corresponding condition listed on this checkboard. Once correct, click any code. Okay. Okay, I click this one. No, this A. Next, analyze urine. Okay, which is diagnosed for this four? 1, 2, 3, 4 diagnosis you show. What is osmolarity is normal. But which is water, ions, have which is urea, uric acid, creatinine, sodium, potassium, and this one. Which one? Normal is
Is it normal?
a normal. 1 minute, first time click. Or A. I think this letter. Yes. Normal, yes, very good, girls. Normal urine is yellow to another in color and continue approximately 95% and 5% are solid. In addition to nitrogenous wastes and excess ions, normal urine may contain many other substances depending upon the individual which is ticked. Next, B. What is this B? Analyzes urine. Osmolarity very low. You see this, which is renal disease, diabetes mellitus, diabetes insipidus. Which one? Osmolarity is very low. Which is disease?
Renal disease, please.
This disease, three diseases, diabetes mellitus, diabetes.
Renal, because creatinine is, I don't know, creatinine is better, I'll be renal.
Oh, these are osmolarity very low. And volume is, I see this volume is increased. Yes, polyuria. Polyuria in which type of this?
So that's polyuria, so that will be probably diabetics.
Diabetes is two types. You have this mellitus and
Diabetes insipidus.
Yeah.
diabetes insipidus. Answer this.
It's
Diabetes
ADH problem, that's insipidus.
Diabetes.
Insipidus. It's ADH problem, that's it.
Diabetes mellitus insipidus. Diabetes insipidus. Okay. Answer this boy is also correct. I touch incorrect. This is very low osmolarity urine, indicating very little watery absorption in the collecting duct. This may result from temporary overhydration or it's chronic from diabetes insipidus. Very good. 2 is correct. Next, third, different colors. Yes, also. Analyzes urine. Osmolarity is normal, but you have this different colors than normal urine. Yes.
Is this one would be renal disease?
Renal disease, I think, very good, but it renal disease, yes. Dark blood. And the dark blood and the excessive protein indicates increased permeability of damage to the glomerular capillaries. This may occur from trauma or renal disease. Very good. Your girls' names, tell me, please. The girl's name, please. I'm waiting. answered correct at this moment? The
It
girls.
was me.
Okay. Repeat once more. I didn't listen.
Sorry?
Your name. Repeat.
Oh, Phoebe.
Fidi.
Yeah.
You are from
The UK as well. The United Kingdom.
United Kingdom. Okay. Very interesting. I think more students from India. No, in this. Okay, and last, this one, no, you see, these are analysis, this urine, no, this last, very high osmolarity, these are names, diagnosis, diabetes
Percent of glucose, that's his diabetes.
mellitus, diabetes mellitus, yes, presence of glucose in the urine indicates that the transport maximum of great work. Okay, these are last quiz for today. And great work. Some of the students answered very good, very correct. And as I didn't know why not answer, not understand, or why I did not know. Okay. Today finished, my dear students. See when you have lecture after tomorrow. And I continue this urinary systems, and then new topic is very interesting. Also, I love endocrine systems. Okay, complete today. Okay, today goodbye from Georgian language. Now,
We have you another lecture. Is it complete today, or we have you the next lecture?
next lecture,
Yeah, we have you for 3 o'clock
Friday.
till 5.
No, I
Is that
said
still okay?
today you did not have lecture. My lecture you did not have. I did not know which lecture you have.
Oh, okay, okay, right. Thank you.
You have my lecture on Friday at 11 o'clock. Okay? My dear students, very bad. I did not see who is who. Okay. If you have questions in next seminar, also I answered this whole question. Okay, goodbye. Nachman this. Bye bye.
Good afternoon.
Good afternoon, ma'am. Good afternoon.
Good afternoon. How are you?
We are fine. How are you?
Thank you. Are you here in Tbilisi?
No, we are not. I'm not into busy. I don't know
Ah,
about others.
okay. What's the situation in your country?
It is very worst.
Mm,
Worst.
yeah. Okay, I think we have to start. Yes, because not many students are today, but anyway. So I think topic you know, yes, the endocrine system. Yes, endocrine. Today our topic is again endocrine system, part of glands. You know from previous lecture, and today we will continue to talk about other endocrine glands. And which glands we know? We know pituitary gland, yes, which is very specific because has two different parts. Yes, very different parts are the anterior and posterior pituitary. And anterior pituitary, you know, it forms from the developing mouth, and the posterior pituitary from developing diencephalon. Yes, and yes, but I am talking about the glands from the last lecture. Yes, if you want, I can. Yes, I can share. Now is better. Okay. So the pituitary gland, I can show. Yes, the pituitary gland, the small structure. Yes, two different part, and anterior pituitary produces many hormones, and the target organs are different target organs. Yes, you know, the, for example, thyroid gland, the testes, ovaries, connective tissue, so the many different parts of the body. And posterior pituitary, you remember, yes, it secretes hormones, but these hormones are produced not in posterior pituitary but in hypothalamus. Yes, especially into nucleus of hypothalamus. Then, and you know, pituitary gland has very closer connections with the hypothalamus. Then, next gland, which you also
Sorry,
know.
doctor, we can't see your
Yeah.
slide. We can see your screen, but we can't see your slide. You need to click on the slide. Please, we can't see your slide, please.
You cannot see?
We can see your screen, but we can't see the slide.
Oh, I don't know why it's such problem. Okay, I'll try. Now,
Yes.
what about?
No,
Yes.
no.
Okay. Then about pituitary gland, so you know, and the next gland, which also you know, it's adrenal. Yes, adrenal gland also has two different parts, cortex and medulla. Yes, the cortex forms from the mesoderm, and you remember, yes, the different zones are in cortex, and also many hormones are produced in cortex of the adrenal gland, and the medulla forms from the neuronal crest, and hormones also, you know, which are produced into the medulla, the epinephrine, norepinephrine. And we talked about the pancreas. Yes, the pancreas, such as the part of the endocrine system. In pancreas, endocrine cells are only 1-2% of all pancreas. The other part of the pancreas is the exocrine. Yes, senor cells are here, enzyme secreting cells, only 1-2%, and especially these islands are located in the tail region of the pancreas. So these glands, you know. And today we'll continue to talk about other glands. These are a pineal gland, also very small structure, and then thyroid gland, very popular in Georgia. This is thyroid gland, and also parathyroid glands, the small structures embedded into the capsule, into the posterior part of the thyroid gland, and about diffuse endocrine system. Okay, starting from the thyroid gland. The thyroid gland, you can see here, is a butterfly-shaped structure, has two lobes united by this part. The isthmus is this part, and thyroid gland is well vascularized. You can see so many blood vessels. Yes, so many blood vessels are here, and the hormones of the thyroid gland are thyroxine T4 and triiodothyronine T3. Then covered by capsule, connective tissue capsule, and then this connective tissue enters into the deeper regions of the thyroid gland, and divides into the different lobules. And now I'll show these, the lobules, and in each lobule are located such structures, round structures, follicles. Yes, these structures. So approximately 20-40 such follicles are located in lobules. And so very interesting gland is this. Why? Because the hormones here are stored not inside the cells, but outside. Yes, outside the cells, into the lumen. Yes, this is lumen, and these lumens are filled with colloid, gelatinous mass, the colloid, and here is hormone, more precursor of the hormones, thyroglobulin. Yes, here is thyroglobulin. Around these lumens are located epithelial cells. I want to show. Yes, around these lumens are located epithelial cells. Usually these cells are cuboidal, but the shape of these cells depends on activity of these glands. When the gland is very active, hypoactive, these cells become columnar, not very tall, but the columnar. And when the gland is hypoactive, so the not active, these cells become flat cells, and squamous cells are located around the lumen. And also when the gland is very active, forms the many follicles. So many follicles are in hypoactive glands, many follicles, and the cells are columnar cells. So the specific, what is specific, you know, because the storage proceeds outside. Yes, not the granules are into cytoplasm of these cells, but the colloid is filled with this hormone, with thyroglobulin. And also it's interesting here is, so the enough thyroglobulin with additional synthesis, it's enough for during 2-3 months. Then, and another, these cells are follicular cells. And yes, also the thyroid gland, it's formed from the endoderm, yes, near the developing the basal part of the tongue. So the endodermal origin this gland has. But here are located another type of cells, C cells, yes, parafollicular cells. And these cells are formed from the neuronal crest. They have another origin, C cells. And these cells maybe are located between follicular cells, maybe between follicles. Not between the follicular cells, but more far from the lumen and between follicles. And yes, I want to show now these cells. Okay, so in this micrograph, this is tissue of thyroid gland. You can see capsule, here this capsule, then septum, connective tissue septum, and you know, yes, along, so in these structures run blood vessels, lymph vessels, and then follicles with colloid. Around follicles are located follicular cells, T3 and T4, hormone secreting cells, and then between follicles, or maybe between these cells, are another type of cells, C cells, yes, and the hormone of these cells is calcitonin. So what's the function of this hormone? This hormone decreases activity of osteoclasts. So when is the elevated concentration of the calcium ions, this promotes activity of this hormone, and then this hormone decreases activity of the osteoclast. So it's inhibitor of osteoclast activity. C cells, but these cells are different cells compared to the follicular cells. Why? These cells more larger, they are more poorly stained. So you can see, yes, more light are these cells compared to the cells of the follicular cells. And in cytoplasm of these cells are numerous granules containing calcitonin. Now I'll try to show. Yes, here. Cells, these are follicular cells, and these cells with more light nuclear, more larger are C cells. Yes, C cells. Yes, here also C cells. This C cell is located between follicular cells, so the inside the basement membrane, and this is outside the basement membrane, another C cell. And now about ultrastructure of the cells. So what we can see here, lumen, yes, this lumen. Then around lumen are located follicular cells. The name of these cells, they are thyrocytes, yes, the cells, main cells of the thyroid gland, thyrocytes. Then these cells have apical junctional complexes, of course, the much rough endoplasmic reticulum, Golgi complexes, and they also contain numerous lysosomes. So it's difficult to see here these lysosomes, but these cells are follicular cells. But parafollicular cells, they are more larger, yes, and more light stain they are. They are located inside basement membrane. Why? Because you can, I don't know, is it visible or not? This is basement membrane here, and they are located inside basement membrane. And also you can see here the cross section of capillary. Yes. Then more high magnification of the parafollicular cells. Yes, you can see here the many secretory granules containing calcitonin, and Golgi apparatus well developed. Yes, and rough endoplasmic reticulum also. Again, this is tissue of thyroid gland, follicles are here. How you think this thyroid gland is very active or hypoactive or in normal condition?
In normal conditions, should be very active.
Yes, because yes, you can see here, yes, the follicles and these cells are usually the cuboidal, more cuboidal are the cells, and when the thyroid gland is very active, are visible the spaces, yes, between follicular cells and the colloid. This is in normal condition here. And many capillaries are around follicular cells, and in next micrograph are stained capillaries, so the endothelial cells. Immunohistochemical method was used for endothelial cells. Yes, these are all the capillaries, endothelial cells around. So this gland is well vascularized. Again, thyroid gland here, these are capillaries here, the capillaries. This parafollicular cell, and all these are follicular cells. They are cuboidal, low columnar cells here. And this is parafollicular cells, so very easy to find parafollicular cells in high magnification. Why? Because here are such, yes, the vesicles, numerous vesicles are in parafollicular cells. Follicular cells without granules. Basement membrane, you can see also here is basement membrane. Then, so the production of thyroid hormone. This process includes some steps. So what proceeds here? The first proceeds production of thyroglobulin. Then proceeds uptake of iodide from blood. The next step is iodination of thyrosyl residues in thyroglobulin with either one or two atoms occurs in the colloid after oxidation of iodides to iodine by membrane-bound thyroid peroxidase on microvilli surfaces of thyrocytes. Yes, on the surfaces, these thyrocytes have many microvilli. Then the next step is formation T3 and T4. Then proceeds endocytosis of iodinated thyroglobulin by the thyrocytes. And next step is so the uptake of these hormones by capillaries. So it's something the complex, the more difficult. Yes, the process of formation of these hormones. Now about some disease of thyroid gland. So this is hyperthyroidism and the hypothyroidism. In both conditions, in both cases, proceeds enlargement of this gland. Why? During hyperthyroidism forms many new follicles, as the many follicles, and the cells become the columnar. But is hypothyroidism with reduced thyroid hormone level. Also, something proceeds the enlargement of this because it's adaptive something condition for organism. Yes, it needs the organism needs hormone. I like these, but I think you have seen such women, men, yes, with enlargement of these gland. So the tissue, it's indicates these microscope indicates hyperactivity of this gland. Why? So you can see such, yes, these species proceeds very active utilization of collate, yes, forms the very high quantity of these hormones. So hypo and hyperthyroidism. Then, so the thyroid gland, I think you know. The next gland, more these are glands. Yes, these parathyroid glands. Small structures, very small structures embodied here, yes, into the posterior surface of the thyroid gland, and they form from the pouches, yes, the upper embryonic pharyngeal pouches, yes, the upper to the superior glands from the fourth pouch, and the inferior from the third pouch. And if you have listened lecture, sometimes proceeds during the development of these glands some defects. So why? Because these glands are attached to the thymus, because the thymus also forms from the same pouches. Yes, and the hormones of the parathyroid. This hormone is important and influence on calcium level. Yes, calcium level. This parathyroid hormone increases calcium level. So its influence on osteoclast and activates osteoclast. And cells of the parathyroid glands. Two different types of cells are here. The main cells, hormone-producing cells, are principal cells and chief cells, principal chief cells, like these. Yes, these cells are. They are basophilic cells, small cells, and here also are another type of cells, oxyphil cells. Yes, these are oxyphil cells, and they are more acidophilic and larger than principal cells. And now, but these cells are not hormone producing cells, more so to say they are passive cells. In some cases, also was found some hormone here. Sometimes they also produce, but very low quantities, and so these cells are transitional, yes, between the principal cells and the passive cells, because oxyphil cells are more numerous in adult individuals, in old individuals. Then, and yes, here, parathyroid hormone, yes, has three major targets. Osteoblasts have receptors, and the parathyroid hormone influence on receptors on osteoblasts, and osteoblasts produce osteoclast stimulating factor that increases the number and activity of osteoclasts. Yes, and the resulting resorption of the calcified bone matrix and release of calcium ions increase the concentration of circulating calcium, which suppresses parathyroid hormone production. The effect of parathyroid hormone on blood levels of calcium ions is thus opposite to that of calcitonin. So calcitonin decreases and the parathyroid hormone increases osteoclast activity, so it leads to the calcium ions concentration. Yes, the first calcitonin decreases calcium concentration, parathyroid hormone increases calcium ions concentration. Then, in the distal convoluted tubules of the renal cortex, parathyroid hormone stimulates calcium reabsorption also, and also parathyroid hormone indirectly increases the calcium ions absorption in the small intestine by stimulating vitamin D activation. So, calcium concentration, monitoring of the calcium ions concentration is the main function of the parathyroid gland. Then, so here in this microgram, this is capsule. Yes, the capsule of the thyroid gland. You can see the thyroid gland. It's very easy to find in micrographs because follicles are well visible. Yes, the follicles, and this is parathyroid gland embodied into the capsule of thyroid gland. Then, so now what's the specific for this gland? Adipocytes, adipose tissue. So when we can find in micrographs the gland with many adipocytes, it means that is parathyroid gland, especially in old individuals. Yes, approximately 50% of the tissue is adipose tissue. So here, yes, the cells, active cells, principal cells, and between these cells you can see adipose tissue. Here also. Principal cells, capillaries also are visible around and between the cords of the principal cells and oxyphil cells. So I think they are different cells. Yes, the cells, the principal and oxyphil cells, acidophilic and larger than principal cells they are. And next gland, pineal gland. Small gland, very small gland. It's formed from the neuroectoderm and is attached to the brain, and cells of the pineal glands are pinealocytes. And so these cells, yes, all these cells are pinealocytes. So pineal gland, this gland, it's not such vascularized, such thyroid gland. But here are numerous nerve fibers, unmyelinated nerve fibers. And function of this gland. So the pineal glands, pinealocytes, these cells secrete melatonin. And the secretion of this hormone is promoted by darkness, and these cells are less active in daily light. And so the function of this is regulate the daily activity. Yes, it's daily activity and its influence on activity of other glands, also hypothalamus, pituitary gland, on activity influence on activity of other glands. So the main cells are pinealocytes, yes, pinealocytes, but here in this gland we also can find another type of cells. They are glial cells, modified astrocytes, and in this micrograph also we can find these cells because they have more elongated and dark stained nuclei compared to the pinealocytes. And specific for this gland, such structures. So these, the name of this, corpus arenaceum, the corpus arenaceum, without any function. These structures are concentration of magnesium and the calcium salts. And the number and the size of these structures increases with the age, but again, without any function they are. It does not mean any disease or something pathological condition of this gland. Then, okay, so here in this micrograph, so pinealocytes, yes, hormone secreting cells, pinealocytes are these cells, and the astrocytes. Especially astrocytes are located near the capillaries. And the part of the corpora cell, corpus arenacea, the same. Yes, you can see so large here is this structure. And many myelinated fibers are in this gland. Only one function of these structures. So, yes, these structures are the salts of calcium and magnesium. Yes, so these structures can be used as landmarks for the midline location of the pineal gland in various radiological examinations of the brain. And so by these structures it's easy to find this gland because this is very small structure. And tumors originating from pinealocytes are very rare, but they can be either benign or highly malignant. So, and now, so this about the glands. Yes, the glands, endocrine glands, but also are cells which have endocrine function. And these cells are located in different parts of the body. For example, they are located in digestive system, in stomach, in intestine. They are located in respiratory system. They are located in heart. They are in kidneys. Yes. So in digestive system, you know, like, yes, these cells enter endocrine cells. They secrete hormones which influence on activity of other cells. For example, in stomach, on activity of parietal cells. And in respiratory, yes, system also are. And the endocrine cells, which are located in the digestive system, in respiratory system, they secrete molecules, active molecules, like serotonin, which is secreted by these cells of central nervous system. Because these cells have such a name, diffuse neuroendocrine system. But in other organs also are endocrine cells. For example, in kidney, yes, in kidney, renin secreting cells. Renin secreting cells, juxtaglomerular cells, yes, modified smooth muscle cells. They also, these cells have endocrine function. And erythropoietin is produced by interstitial fibroblasts in the kidney in close association with the peritubular, capillary, and proximal convoluted tubule. It is also produced in perisinusoidal cells in the liver. So these cells also have the endocrine function. In heart also are cells which have endocrine function. In atria, for example, atrial natriuretic peptide, hormone secreted by the atria of the heart. It's lowers blood pressure by causing vasodilation and by stimulating the kidneys to excrete more water and sodium, yes, which lowers blood pressure by reducing blood volume. So these cells which are located in heart, in kidneys, in digestive system, all these cells have endocrine function, and they form diffuse endocrine system. Here, this endocrine cell is this. This micrograph shows somatostatin secreting neuroendocrine cell in the gastric mucosa, and in cytoplasm you can see many electron-dense neurosecretory vacuoles. Yes, usually such vacuoles are spherical, and these vacuoles are usually located on the basal part of the cells, not like the exocrine cells. Yes, exocrine cells contain vesicles, secretory vesicles, granules on the apical part of these cells. Okay, now yes, now I want to show. Have you any questions about this part? I want to show histology guide. Okay, I think no question. No question. Yes. Okay, now I'll show histology guide. Is it is it visible? Yes. Yes. Okay. Thank you. This is a thyroid gland, and I said it's very easy to guess that this is thyroid gland. Yes, because specific tissue here. Yes, very specific tissue. And capsule covers thyroid gland. Then connective tissue extends inwards from the capsule and divides into the lobules. So I want to show these. Yes, such trabecular. Yes, trabecular. All these are connective tissues, and yes, blood vessels. Yes, these are blood vessels. Arteries here, and then now thyroid follicles. Okay, lumen with colloid you can see here, and follicular cells. Now I want to show more high magnification of follicular cells. Yes, follicular cells. So they are cuboidal low columnar cells, like these low columnar cells. The cuboidal cells are around this colloid, around lumen. They are blood vessel. Yes, here the capillary, or here follicular. All these are follicular cells. And now parafollicular cell. Yes, this is parafollicular cell. Yes, parafollicular cell, this one. And another parafollicular cell, it's also. So the first one was outside the basement membrane. This is inside the basement membrane. Yes, the basement membrane. Connective tissue, you can see here. So I think to guess that this is a tissue from thyroid gland, it's easy. It's very specific structure, has thyroid gland tissue. The next gland, parathyroid gland. So it's also easy to guess why. Adipose tissue, yes, inside This gland in between principal cells are many adipocytes. So the capsule, yes, connective tissue capsule, you can see. Then trabecular, I want to find trabecular, yes, connective tissue trabecula with blood vessels. Yes, the many blood vessels are here also. Then chief cells. Yes, chief cells. Less such basophilic these cells are, and oxyphil cells. Yes, acidophilic they are and larger than principal cells. And adipose cells. Yes, adipose cells. Especially in adult. Yes, especially in adult individuals. And okay, so this individual, this is middle-aged, yes, not very old individual, but the approximately 30-35% of the tissue is adipose tissue here. And I don't know, unfortunately, we don't have a pineal gland, but I want to show only these. So what we can see here, this specimen is unusual in that a parathyroid gland is embodied within the thyroid, which itself is fused with the thymus. And this occurs when parts of each tissue fail to migrate to their proper location during development. And I'll show all these parts now. The first, thyroid. Yes, the thyroid gland, thyroid follicles are visible here. Then parafollicular cells. Yes, so the follicular cells, parafollicular cells, and now parathyroid. This is parathyroid gland. So all these cells are principal. Yes, principal cells. More low magnification I want to show now. The thyroid gland, yes, thyroid gland and parathyroid gland. And near these structures, we also can find thymus, this. So, do you remember what's the function of thymus? Who can answer? What's the function of thymus? Are you here? So this is thymus. Yes, thymus is lymphatic. It's the lymphatic organ. The thymus is the primary lymphatic organ. So like the bone marrow. Yes, bone marrow and the thymus are primary lymphatic organ, and we also know the secondary lymphatic organs. So what's the difference between the primary and the secondary lymphatic organs? The primary lymphatic organs. First, the formation of the cells starts in bone marrow. Yes, the part of these cells migrate into the thymus, and the formation of these lymphocytes proceeds in primary lymphatic organs. We know B lymphocytes, T lymphocytes. Yes, the T lymphocytes forms in thymus. B lymphocytes in bone marrow. But what's the function of the secondary lymphatic organs? In secondary lymphatic organs proceeds activation, yes, then of these cells, but the formation proceeds in thymus in bone marrow. So this is thymus. Okay, so all these structures we can find together, yes, in this micrograph. Okay, do I want break?
Yes, please. 10 minutes.
Yeah, 10 minutes break, then we'll continue. Okay, 10 minutes.